For the snapshot of the hyperbola function, it's good to remember that when that is your formula, then you know you've got a hyperbola, which will always take the form of two parts. There'll either be a top right and bottom left, or there'll be a top left and bottom right, and that is dictated by your a value. The a value tells you positive, those two, and negative, those two. Your q value will have shifted the graph up and down and changed the asymptote. The vertical asymptote is always, for these graphs, going to be that line, the line x equals 0, but your horizontal one will change depending on the q value. Okay, an asymptote is a line that the graph approaches, but it will never touch the graph and it will never cross the graph. When we are drawing these graphs, we need to find the x-intercepts, if there are any, and we need to find y-intercept if there are any. For these ones, there aren't going to be y-intercepts, so you can know actually from the word go that there won't be any. Because you won't have a y-intercept, you need some other points to plot, and so we use the strategic table method to be able to plot the hyperbola. You're going to get your horizontal asymptote, you're going to get an x-intercept if it exists, and then you're going to use strategic table method. What is strategic about this table method is that you are finding points for x that are going to factor into your a value. In here it was 6, so we tried to get ones that factor in so we can plot nicely. Remember that you will have your two axes of symmetry and that they will cross each other at the same place that the asymptote cuts the y-axis. Remember to plot all of your points as you go. Here is another example of a drawn hyperbola. This one is a top left and bottom right because the a value is negative. It's also shifted down, making the asymptote -1, and your two axes of symmetry cross each other on the y-axis at that point -1. Okay, here's a good time to remind you that the axes of symmetry, you know the point that they cross the y-axis will be their q value because they're all straight line graphs, and their a value, their gradient, will be +1 for this one, which slopes to the right, and -1 for this one, which slopes to the left. Calculating the axes of symmetry is calculating their formulas for their straight line graphs. You'll get that from the asymptote of the hyperbola, which you already have, and you know the gradient is either 1 for slope to the right or -1 for sloping to the left. For example, here you could have a hyperbola where you have the asymptote and you have the two lines of symmetry, and you're going to plug in that asymptote for the lines, q values, and then their gradients will be different. To calculate the domain and range, you're going to look at how far left and right and how far up and down. For a graph like that, where, just a reminder, that's what it looked like, you're going to have x could be anything except 0, and y could be anything except the asymptote. So this is a really handy way to write the domain and range of a hyperbola. Hyperbola questions enjoy quite a few reflection ones, and we need to remember that if the a value is negative, you're going to have your top left, bottom right, and if the a value is positive, it's going to be top right, bottom left. There you have an asymptote of -1, there you have an asymptote of -2. So a question is quite common would be, how has this become that? And it is that it has been reflected in the x-axis and is shifted down by 1, because to get from -1 down to -2, you've got to shift down by 1. The values for which a graph increases or decreases is your ruler test again. These ones either increase, like these ones here, going up, or decrease, like that one there, going down. So they increase for no values of x and decrease for all values of x, or the other way around. Except for, of course, at the asymptote, so at that point there, at the 0, that is not included. So make sure that you write it in a way that makes it clear it's not doing anything at the point where x is 0. When we find the equation for a hyperbolic function, we could be given a number of things. We could be given the horizontal asymptote, in which case we plug it straight into the q value of the formula. We could get given a point which has an x and y value. That will go into there by your x and y. Your asymptote, whatever it is, goes into q. You solve for a. Once you get a out, you need to put it back into standard format, or you haven't solved the problem. An example here, you have a hyperbola and you have its two lines of symmetry. And to be able to work with that, you could be given that, and then you've got to work with where the lines cut each other, and that will give you your horizontal asymptote. So you could also be given lines of symmetry, and those could be used to find the equation of the graph, or the other way around.